Welcome to another edition of Building Talk. I'm Bryan Falk. I've got Ben Rufenacht with me, and he is going to talk to us about stormwater retention. Ben, do you want to reintroduce yourself? You were with us last time, but please tell me a little bit more about yourself and reintroduce yourself in case they missed the last episode.
So I am a water resource engineer specializing in surface water modeling that pertains to any kind of flood control, dams, levees, and city stormwater systems.
Excellent. So I'm an architect. This podcast is for people in the building trades, engineers, building owners, contractors, and we often come upon the need to build stormwater retention in our projects, and that's something you have some specialization in. My understanding is the city of Topeka requires it over a certain size, which I think is about an acre. Is that correct?
And it varies, so this is going to vary city to city, but some of them have, if you're disturbing land over a greater size, then they require you to provide some sort of retention, and it's also in Topeka particularly, it's actually different areas have different rules. So if you're building out in the county, you don't really have to follow any rules really, and then compared to when you're building in certain parts of the city, and it's actually certain drainage basins in the city's drainage basin based.
Okay. Tell us a little bit about the difference between retention and detention ponds.
So, well, I don't know. That's basically the same thing.
Basically the same thing, just another word. It retains it versus detains. It's just two different ways of saying it.
Yeah. And I think there's some maybe minor differences, but
yeah. What about, you've talked to me about in the past swales and their uses. How can we use swales and like kind of living gardens to retain water? And how do you compare that to a retention pond?
So traditional retention ponds would just be, you're just building a hole in the ground that has kind of a dam structure that allows overflow to go over it over a certain amount, but the city requires you to hold back the 25-year storm, the 50 storm. They have, they're different in every place, but so you build your hole in the ground big enough to hold that much water, and you just let it overflow. When it gets over that much amount, you provide some sort of overflow for it, and that's like the easy engineering way out, kind of, and the easy building way out. And then so the more modern way to do it would be to you're trying to go back to nature, basically. So you build a more natural, a more aesthetically pleasing area where you just put little swales into your ground. So you just put small divots instead of just a big hole that holds as much as you need it to. You build these kind of small natural flowing divots in the ground, and they kind of hold back water. And then the other thing you kind of design these to do is to absorb the water fast. So you put a lot of plants in them. You put trees in them. Trees will suck up water faster than anything else. So they have the infiltration, and then they have the evapotranspiration, as we call it, the plants taking the water up out of it. So that's the more natural way. And they also slow the water down, whereas a traditional, if you just build think of a sewer city gutter going into a storm concrete pipe under the ground and sending it straight to the river, that's all happening really fast. It flows over the concrete, the asphalt really fast, goes into that system, flows through that pipe really fast, and gets to the river fast. Whereas through these bioswales, it's moving very slow. It's going slowly through the grass, it's going slowly, it's falling in the ground as it goes, and in a much smaller amount, it also has the secondary effect of cleaning the water. The grass and the ground is acting as a filter.
Cleans out vehicle oils and other
any
toxins.
Any kind of stuff that, your fertilizers you throw on your grass or anything like that.
Yeah. Tell us about underwater containers or underground containers, I should say, that sometimes can contain the water and slowly percolate it into the soil. How does that differ than a typical system, and how much more effective are they?
So that's just the way that, builders have gotten around this. Well, I can just put this big underground system underneath my parking lot, so I can still take advantage of the ground instead of just having this hole in the ground that I can't use for anything, and then they tend to get kind of ugly because nobody takes care of them. So they just put it underneath the parking lot, and they'll put these, essentially they're just very large pipes underneath the parking lot, and those will hold, and they'll usually put a gravel bed underneath them, and they'll be perforated or something, and then so the water can just slowly, works the same way as a bioswale, only you don't have that extra effect of the grass and the trees sucking it up. You just have it soaking down into the ground. And
you would only do that when it's a hardscape above. There's no reason to do it if it's plantings or grass above the container.
Right, yeah. Well, you'd have trouble having your plantings and grass if you stuck that down below it, probably, unless you stuck it extra deep and it just the cost wouldn't make sense unless you were taking advantage of that area in some other way. You needed it for some other way.
Okay. Talk to us a little bit about why cities are requiring this, what the advantage is, and how it saves cost on infrastructure to the cities.
So they require it because, if you think about it, you pave everything over. We just let this become a giant parking lot and streets and buildings, and that's all we have. All the water that falls on this area is now, none of it can be soaked into the ground. All of it's going to run through the stormwater system. All of it's going to run very fast down to the river, and it will concentrate faster in the river. So you'll have a higher peak flow moving at a much larger speed, which can cause much more flood damage. So to avoid that, we're trying to, traditionally that's what we did at the big infrastructure buildup in the 50s. This was the idea. We're just going to get this water out of here. We don't want it hurting our buildings. We want to just get it out of here, get it to the river. But then we realized, it's got to go somewhere. Now we're hurting everything. Now we're hurting the river. So this is kind of a let's go back to the way it was before and try to slow it down and kind of mimic a more natural system.
Is it almost underground water? Is it almost talk to us about aquifers versus just the water soaked into underground in a typical situation. Aquifer is almost always a sandy bed below ground. Is that right?
So aquifers are generally deeper. So aquifers are usually they almost have they'll have almost a clay lens layer above them, and then below them, and they kind of have this sandy, rocky. It'll be or a shale or some sort of porous material kind of between the two that's holding the water. And generally, that's the big aquifers are all kind of separated from this water that's just soaking into the ground. Now, water eventually soaks down into there, but it takes a long time to get down there. So then the water that's soaking into the ground up high, that's just, it's mostly just used by plants, or it can actually eventually get back into the river.
So is an aquifer really water, or is it a mix of mud, water, sand?
It's water filling voids. So it's water filling in the voids that are left in sand. So it's not it's not like these underground pipes that we were just talking about. Underneath the water, there's not this big void. It's a bunch of tiny voids in gravel.
You hear so much about the aquifers being depleted. What are the causes of that? Is it related to agricultural usage? And the water's got to go somewhere. Where is it going?
So, like I said, these aquifers are generally these things very deep down into the ground. They're deeper than what water just normally soaks regularly. So, for example, the Ugal Aquifer, western Kansas, we've been depleting it like crazy. So, and it doesn't rain much out there, so you got a secondary effect there. So they're sucking out way more water to water their crops than the rain can replenish as it slowly soaks down there. So that's just you got a deficit there. You're taking out more than you're putting in.
Excellent. So it doesn't really have probably a whole lot to do with urban usage, but I was just thinking about water going into the soil and how that related to aquifers.
And some cities do get their water supply from aquifers. So.
Oh, interesting. Okay, so what other types of retention are there that maybe I haven't asked you about? There's the ponds. There's the I think I've seen some people actually build up parking lots and put like a stem wall at the end of the parking lot, so the parking lot acts as the detention pond. Is there any other unique applications or unique ideas related to detention?
One thing is pervious pavement. So people will pave over their parking lot with a pavement that actually allows water to soak through it. So it acts more like natural ground. So the water actually, you do lose some water by just soaking it straight through the pavement. That stuff I've seen mixed results with that stuff. It tends not to hold up as well. At least the older stuff tended not to hold up as well. I think newer stuff is quite a bit better.
I've heard you have to clean it, and that if the pores of the concrete get dirt in it could prevent that process from occurring. Is that true?
From the studies I've seen, even with it, clogged up at 98% clogged, it's still effective.
Oh, really?
So it's still allowing enough water down to be a useful tool. And then, and the best way to do it is combine all these systems. So you have your pervious pavement, and then instead of putting curb and gutter on the edge of your parking lot, you put little bioswales, and then you put plantings, and then you can even put them in the middle of between the rows of parking. So you put these little bioswales, so the water that runs off goes into a bioswale where there's nice trees and plantings there, and then you have parking on either side of it, and another bioswale. So it's this kind of system.
Do typical cities allow that, or do they really want to see those curbs?
Depends on your city. And I mean, some embrace it. You go to, my favorite is Portland, Oregon, is a perfect example of a city that's just embraced it. And it's got these just beautiful examples of how you can use bioswales and bioretention in a beneficial way. And it's people fight it at first because they think it's going to be ugly. But then you put it in, you realize, no, this actually looks way better than a curb and gutter.
Well, a couple blocks from where we're sitting now, there's the Jackson bioswale, right? And has it required much maintenance to keep it going?
So
it looks pretty rough to my eye right now, but tell me a little bit more about
the
that
city
project.
has had. I know the city has had some maintenance issues and some complaints about how much it takes maintenance, and that's a common thing you hear with city. That's why cities fight it. It's like, oh, I don't want to take care of that. I just want it to be a curb and gutter. But if they're properly maintained, it can be not that bad.
I think I've seen one out in Rossville near the pool. Have you happened to see that? It's beautiful. So it can really add to the aesthetic of a city and a building if it's done properly, but it does take time and maintenance.
Yep.
Yeah.
And there's I mean, you just turn it into a big park. It's just your park is a giant bioswale, which kind of the Shunga Park is kind of quasi that. It's not really designed that way. But
so a bioswale could just be grass?
Yeah. Grass works great because grass both soaks up quite a bit of water and it provides really good filtering.
So grass isn't a lot of maintenance. Right?
No, it's not. And
So
you can do around here. You can do native grasses, so you don't even mow them. You burn them off once a year, which is what they do along the Shunga. There's areas
and they look really nice.
And they look really nice. Yeah.
Mm-hmm. So why that seems like a more cost-effective solution than curb. Curb is pretty expensive solution to this problem, and it doesn't appear to be solving it as well as a bioswale. What's the resistance?
I would agree. It's just
people don't even want to mow.
It's the same resistance you get with any new technology, new thing, new idea. Is the old people want to do it their old way. They're stuck in their ways. The engineers want to design it the old easy way because designing curb and gutter is quite a bit easier than designing bioswales. And not everybody knows how to design these or how to take care of them. People don't know how to maintain them, so they don't know exactly what to do for maintenance. So it's just it's a learning process.
So let's do a scenario here. There's a new building, and it's on a empty lot that's currently just grass, so 100% absorption into the soil. They want to put a 5,000 square foot building with a 10,000 square foot parking lot. And it's over the 1 acre, so it triggers a retention pond. Instead of a retention pond, you could do a parking lot that just flows over to a bioswale, and that would relieve you of that just by not putting curbs and calling the bioswale just a little bit of a ditch at the edge of the parking lot.
And there's some engineering involved where you go and you actually model this and you make sure that this bioswale is going to be enough to send it back to, basically they go pre-built conditions. So they want the flow coming off of that property to go back to pre-built conditions.
Great. Well, I think you've changed my thinking about parking lot design even in this conversation. I hope this has educated other people out there. Thanks for joining us again. We'll see you next time on Building Talk. Thanks a lot, Ben.